All right, so here in section 8.5, we're going to find the area between two curves, just like we did in 8.4, but instead of doing it with respect to x, we're going to do it with respect to y. There's a couple things you got to keep in mind before you get going in the problem. First thing you want to keep in mind is you need to make sure that you solve the equations. Let's get that back there again. Hold on a second. You got to solve the equations for x. That's the first thing you got to make sure you do. And then we also want to keep in mind that the a and b values are on the y-axis instead of the x-axis. And then the third thing, so 1, 2, and then 3. The third thing is, as we think about the formula we learned on finding the area between the two curves, we had the top curve minus the bottom curve. Now, with this in mind, the top curve in this case is technically the function that's on the right. Is which function is on the right, and then the bottom would be the function that's on the left. So we have several problems we're going to work through. We'll have one problem we'll work it both ways, with respect to x and with respect to y. But here, the first one here says set up the integral that allows you to find the area. And they didn't want us to find the area. They just said set it up. First thing we have to look at is, hey, they do not have it in terms of x equals. So I need to go ahead and square both sides and get x is equal to y squared. On the next one over here, I can just add the 6 over and get y plus 6 equals x. So easy thing there. And then now we go ahead and set up our integral. And let's see, we're using y values. So here I get to use the x-axis, which would be y is equal to 0. So that's my lower bound. And my upper bound looks like, where do they cross? Looks like they cross at 3. And then now, again, as we start writing the inside part with the functions, we want to go with the function on the right. So that's the function that is on the right, is the diagonal line. So that means I have to start with the y plus 6 and then subtract the function that's on the left. Well, that would be technically the this part of the quadratic of y is equal to, or x is equal to y squared. So this is my left. So then we get to go in there and put minus y squared. And then we would finish that up with a little dx. And then again, we can clean it 0 to 3 of negative y squared plus y plus 6 dx. And then we could go through and find out, okay, what is the area of that? If you think about what we did yesterday, we led off with this problem yesterday. Yesterday we did it with respect to x. So when we did it yesterday, we had to split it up into two different integrals because we switched which function was on the bottom about halfway through. And so yesterday we did, from the integral from 0 to 6 plus the integral from 6 to 9. And then we went with, the square root of x minus 0 dx. That was the first half, the left half. The second half was the square root of x and then minus the x minus 6 dx. And that was yesterday's approach to it. So again, both answers will give you the same, both equations will give you the same answer when it's all said and done. All right, so number 2 says set up the integral to find the area bounded by, okay, good, they gave us it's in terms of x is equal to for both of these. And so, again, I'm just going to make a note here that this is the 3 minus y squared, so that's the one that's on the right. And then the diagonal line, this is y plus 1, that is the one on the left. So as I go to set it up, so again, using the y values for my a and b, they touch at -2. And where do they touch again? Looks like they touch at a nice spot at +1. And again, if they weren't nice areas, we'd set the two equations equal to each other and solve for those values. And then we would say, all right, starting with the equation on the right, we have 3 minus y squared. Then we subtract the equation on the left, y plus 1, and then dy. And then, I would always get in the habit of cleaning it up. The integral from -2 to 1 of negative y squared minus y. Then that is it looks like a +2 dy. And there would be my cleaned up version for that one. So the next problem we're going to do, and the last problem we're going to do, is we're going to do it with respect to y. I am going to have it written down here twice, that way it doesn't get all junky on one. So on the first one, I'm going to do it with respect to x. So on this one, I'm going to do respect to x. And on the one over here, I'm going to do with respect to y. Just as I highlight like the values of where they're intersecting and so forth. So we have the equations already set up to where they're in terms of y is equal to, so we're ready to do with respect to x like we did in the previous lesson. I'm just going to label the different equations here just so I have, all right, so this is the y equals x minus 1 quantity squared, because it's got a vertex of 1, 0. This part right here, that equation for that graph would be y is equal to 2 minus x squared. And then, of course, we got our diagonal line, so that would be the y is equal to 3 halves x plus 1. So those are our equations, and again, as we start from left to right, and so they said we can use the calculator to find intersection points, because it looks like they're going to be kind of nasty here, because if we think about it, we know we start at 0, so we start at 0 here, and then they touch somewhere about there is where we change who's on top and who's on bottom of the graph, and then we have the final part of the integral right there. So we're going to use the calculator to find our a and b values, and so I know I'm going to set it up generically. I have from 0 to a, and then the equation that's on the top is the linear function, so 3 halves x plus 1, minus the equation on the bottom is the parabola that opens up, so that would be the x minus 1 quantity squared dx, so that's the first part. And then I need to add to it the second portion, which would be basically from a to whatever that b value is. And on that one, it's the parabola opening down is the top equation. So that would be 2 minus x squared. And then minus, and the parabola that opens up is the one that's after. So x minus 1 quantity squared dx. So now all I got to do is find my a's and b's. Again, we can clean those up, as we go forward. But again, let's remind you how to find a and b. So I want to figure out where does. I'm going to type in all three equations here real quickly, just so we get them. Let's get over there. Here we go. So I'll get into y equals, clear off that junk. All right, so y equals. All right, so first equation would be 2 minus x squared. Second equation would be the quantity x minus 1 squared. And the bottom one would be, I'm going to go decimals, 1.5x plus 1, just to make it easier to type it in. Hit graph, there we go. And again, we're trying to find that small little piece where between the blue, the red, and the black, way down there. So let's start off with, okay, what's the a value? So I'm going to hit second calculate, option 5. And I'm going to get close to gonna get close to on the blue line, of the curve there, and then I'm gonna go over to, all right, I'm hopping on that equation, so I'm on now the linear function, and I hit enter, and yes, I want to guess it, and so that says it's at exactly 0.5, so that's nice there. So again, if I was trying to find the area, an area was represented that, use a calculator. Again, they just want me to set it up. They're not asking for the whole area. So my A is equal to 0.5. Now, what's my B value? So let's see, second trace, intersect. That's close enough. That's good. And yes, I want to guess it. And that says my B value is approximately 1.366024. So again, that, we can clean it up one more time, and we don't have to, but I'm gonna go ahead and try to clean it up a smidge. Let's see if I can do that real quickly. No, I can't, just because that's squared out. So we're not gonna hold off. We'd have to square that sucker out, and it'd be a little bit, crazy if we did it. So let's look at now with respect to y. Again, we already have now the challenge is, and that's why I have the other picture up there, is since we're doing it with respect to y, now that changes what are the values where they're crossing at. And I did a bigger picture here because we'll notice that, yes, it starts here at the y-axis, so we know it's the integral from 0 to something, but actually right up here is where the first intersection is. And so so with that in mind, so that's going to be my first A value. And then I have to add to it, the next integral will be from A until we stay who's on the right each time. Okay, well, really, we get to go right to there. That's my B value. So my B value would actually be the y-intercept of that point up there. So, of that intersection point. So whatever the B is. So let's get our equations set up here, and then we'll come back and find the A's and B's. So now all of our equations are in terms of y, so we're going to have to go ahead and get them in terms of x, where x equals, so that we can put them into our equation. So the first one, if we start off with y equals negative x, 2 minus x squared, that would be y minus 2 equals negative x squared. Multiply through by negative 2, and we get negative y plus 2 equals x squared. And we square root both sides, and I'm just going to switch things around here real quick. X is equal to plus or minus the square root of 2 minus y, just to write it in that manner. So now we do have both of them, because technically, when we look at our picture here, this is the negative side, that's the positive. So that, like, this side over here is the negative root 2 minus y. And then this other side here, this is the positive root 2 minus y. So we really just need the positive one for what we're doing for our down below. But it's always good to keep both of them on there. That way we can see which part's which. My next equation, y equals x minus 1 quantity squared, we would square root immediately, so plus or minus square root of y equals x minus 1. And then we'd add the 1 across and get 1 plus or minus square root of y equals x. Now, with that case, this half right here, this part right here, that is the 1 plus the square root of y. And then the other part, this part of the curve, that is the 1 minus the square root of y, is what that is. So that is being used in both cases. So when you think about our very first integral, we're doing this part of the curve, which is that. And then on the left-hand side would be this part of the curve, which is this part. So we would start off saying 1 plus the square root of y, that's the right function. Subtract the function on the left, 1 minus the square root of y, and then all of that dy. Now, which equations on the right would be this equation? So square root of 2 minus y, then minus, we got to stop. Mr. Stevens just realized we do change right here. So we actually have, we have to go back, actually change something right here real quick and say, you know what, that's actually the 1. So that's going to be a 1 there. So we have a third integral from 1 to whatever that b value is, okay? Again, we still have the 2 minus y square rooted as the right-hand part. Now we got to do the left-hand part. Well, that happens to be the 1 minus square root of y and all that dy. And last here, now finally that little top part there, the equation on the right is square root of 2 minus y minus the equation on the left would be the diagonal line, which we said that we did not solve for yet. So that's the one I hadn't solved for yet. So real quickly, y equals 3 halves x plus 2 if we distribute through, or sorry, plus 1. If we distribute through by 2, we get 2y equals 3x plus 2. Subtract the 2, we get 2y minus 2 equals 3x. And then do we divide by 3 and get x is equal to 2/3 y minus 2/3. So that would be what I would go in next. So then after the minus sign, 2/3 y minus 2/3. And then it's all of that dy. Now, what are the y values? Again, we can just, we have the equations put in there. We just want to pay attention to the y parts, the y answers of each of those ordered pairs. And I guess it would have made more sense to write down each ordered pair. I do have the last one in here, which is our new a value here from down here. That's 0.13394746. Sorry. 0.139746. So that's my a value, my new a value. And then now we know they're touching at 1. And then my b value, so we just go back here and just do another second calculate, intersect, and find out where they're touching right up here. There you go. And it's at 1.75. So that's at the b here happens to be 1.75. So again, we can rewrite that if we want with those decimals in those places. I'm going to hold off. But that's what we're doing. We're just, we're doing things in terms of y, which means we use y values of where it crosses like the y-axis as we're setting up our boundaries. We got to make sure we solve the equations in terms of x is equal to y. And then we use those throughout the problems. All right.